Hello everyone, welcome to Earth to Earthlings. I was supposed to write about the natural fluctuating climatic cycle in the past versus the change we're seeing today, and I'm not gonna lie, that can be a very detailed, long, and potentially boring read. So I am going to make this video to attempt to give you my understanding of the difference. The first thing you need to know is what greenhouse gases do. Greenhouse gases have a huge influence on climate. They trap heat in our atmosphere, so methane, which you can get from cow burps or decaying organic matter inside of a landfill. There's nitrous oxide, which you can get from like cultivating a field for agriculture, or there's carbon dioxide. There's also water vapor, but carbon dioxide, as you all know, comes from like turning on your car, for example, and driving. I'm guilty. Flying, also guilty. Turning on your light if your electricity is coming from a coal-fired power plant or natural gas, you're also releasing carbon dioxide into the atmosphere. So what happens is those gases are released into the atmosphere. The sun's heat comes through that atmosphere. It hits the surface and tries to bounce back into space, but those gases are really good at absorbing that energy, and they're like, nope, you guys are gonna stay right here and we're gonna absorb that heat, okay? So thank God that happens, because without those gases, the Earth would be a frozen planet because space is a really, really, really cold place. This is a natural phenomenon, and thank God it happens, or else we would not be here today. So let's talk about the fluctuating climatic cycle in the past. Long time ago, when the Earth was forming, there was a lot of molten lava. This place was super hot. But fast forward to when the atmosphere could support living things, for example. There were are tons of factors that play into what our climate looks like ocean circulation, for example. Volcanic eruptions can make the place colder. Mountain ranges can change wind circulation and change how things interact with each other. A meteorite hitting the Earth can spew up a bunch of dark matter into the atmosphere, and it blocks the sun's light from hitting our planet and makes the whole place a lot colder. Concentration of greenhouse gases in the atmosphere, obviously, because they trap heat, has a really big effect on climate, aka long-term trends of weather. Something that can influence the concentration would be a living organism on the planet. For example, like a sea fern that absorbs a ton of CO2 in its body, and instead of that CO2 being in the atmosphere and trapping heat, it is in that organism's body and the whole planet gets colder, right? So as you can see, there are tons and tons of factors that contribute, and scientists cannot account for every single one, but they do a really good job at thinking about a whole bunch of them. So for the past the past 1 million years, scientists have seen that we have fallen into this cycle of interglacial and glacial periods, right? So that happens about on average every 100,000 years. And the reason for that, which is what I'm going to talk about when I say the natural fluctuating climatic cycle, I'm only going to talk about the last 1 million years, which on a geological timescale is very small, but for our lifetime, that's a good thing to think about. You know, we don't really need to be thinking about the next billions of years, because the Earth will survive us all and we'll be gone by then, but we don't have to think about that. So anyways, to talk about stuff, you know, a relative time frame that matters for us, let's talk about that 100-year fluctuating cycle. This is due to the Milankovitch cycle, which is a 3-whammy effect that causes interglacial and glacial periods. So what that means is that Earth's orbit around the sun changes. Right now, the sun is very centered in Earth's orbit, and we're going around, you know, just going around, and we pretend my head is the sun. This is the Earth, and since the sun is very centered in Earth's orbit, there's a lot of sunlight that's proportionally hitting the Earth at any given time of the year, right? And we've been in that cycle for a while. Gradually, over 100,000 years, that orbit changes more into an elliptical shape, and it gets further like an oval. So what happens if we're out here, the northern hemisphere, where most of the landmass is like this, and it's way out here, and then also part of the Milankovitch cycle, the tilt of the Earth changes from this to this. If you're way out here, you're tilted this way, and then you're wobbling more like this space over here is going to be extremely cold because it's not getting any sunlight. Remember, my head is the sun, and boom, sorry, Alaska and everybody in the northern hemisphere, you're really, really cold. That is when we get an ice age, okay? So for the past million years, that has been the biggest contributing factor to climate.